Hello. Today we're going to look at lesson 1.2.3, which talks about slope of parallel and perpendicular lines. And then we're going to do some practice with reflections. So first, the learning target. Students will recognize the relationship between slopes of perpendicular lines, and they will practice with more difficult reflections. You should always know what you're supposed to get out of a lesson and know those learning targets. The vocabulary. Parallel lines are lines that do not intersect. Railroad tracks. Parallel lines. They never intersect. Perpendicular lines. It's not enough to say lines are perpendicular. It says that they intersect. It's a special angle that they form. So lines that intersect at a 90-degree angle. So these lines make a 90-degree angle. I'm sure you've seen before the way we mark a right angle and 90 degrees is the little box. So parallel lines that never intersect. My hands, right? I could grab a pencil and a pen. Parallel lines. Perpendicular. Make a 90-degree angle. It could be this way, but they're still forming a 90-degree right angle. What do you think is true about the slopes of parallel lines? Slope is how much the line tilts. So if the lines are parallel, what do you know about how much they tilt? Wouldn't they have to tilt the same amount? So parallel lines have the same slope. Now, we need to look at slopes of perpendicular lines. We're going to do that by looking at this line, the line y equals 3/4 x plus 1. So we're going to graph that line, and I really hope from Algebra 1 that looks familiar. Y equals mx plus b, the equation of a line. M is the slope, b is the y-intercept. So in y equals 3/4 x plus 1, my b is 1. My y-intercept, my starting point is 1. And my m is 3/4. So from that 1, from the b, I go up 3, right 4. And I can keep making up 3, right 4, and I get a line that looks like this. There's my line. This is called a slope triangle. It's the triangle that I'm drawing in when I started at 1 and went up 3, right 4. I could have drawn it this way or this way. So this length, rise is 3, my run, my across is 4. So 3/4. Rise over run. So now what I want to do is I'm going to rotate this triangle. So the easiest way to do a rotation is to trace the triangle on tracing paper. So I am tracing this triangle. There's my 3 and my 4. And I'm going to draw in a little X, a little plus sign here at the axis so I know I line it up and I went exactly 90 degrees. So it says I'm going to go 90 degrees clockwise. A clock goes this way. So 90 degrees clockwise is going to take that triangle down here. And we'll practice rotations more in class. But right now, all I need you to do, you don't need to know how to do this. You need to know in this lesson just how to look and see that this triangle moves to here. And I want you to look at what happens with the slope triangle. See how the rise was 3 and the run was 4? Now they've switched. And even more than that, doesn't it go down 4 instead of up? So the slope in the first triangle was 3/4, rise over run. In my new slope, it goes down 4, right 3. Down is negative slope. Do you remember in Algebra 1 that if the line goes this way, up, positive slope, down is negative slope? See how this line now would be negative slope because we rotated it 90 degrees. So the important part of that is down here. Slopes of parallel and perpendicular lines. And there's two things you need to know. Parallel lines have equal slopes for parallel lines. For perpendicular lines, the number flips. So up here, it went from 3/4 and it flipped and changed, right? It became negative. So if I put that tracing paper back up there, you can see it became negative 4/3. Negative 4/3. So this number and this number are opposite. Flip the fraction and change the sign. We call that opposite reciprocals. Flip the fraction, change the sign. So if lines are perpendicular, their slopes are opposite reciprocals. Flip the fraction, change the sign. If lines are parallel, their slopes are equal. That's what you need to know from this page. You need to know this. There will be yellow closure notes in another video for you to fill out with that. Don't do that now. So parallel lines have equal slopes. Perpendicular lines, slopes are opposite reciprocals. That's the first thing you needed to get out of this lesson. The next thing we need to talk about is more with reflections. So let's take a look at this next problem. If you're doing a reflection, if you want, or a transformation, we want to get from A, B, C, D to A prime, B prime, C prime, D prime. There are two ways you could think of this. You could think of this as a reflection, but it's not a reflection over the y-axis because the y-axis is not halfway in between the two. It's way closer to this one than this one. So another way you could think of it is you could reflect it over the y-axis and then slide it. So that's what we're going to talk about. So the first translation is reflect over the y-axis. If I took this and reflected it over the y-axis, I am 1, 2, 3 away from the y-axis, so I'd have to go 1, 2, 3 away, and I would be here. A is 1, 2, 3, 4, 5, so I would have to go 1, 2, 3, 4, 5. C is 4 away, so I would go another 4 away, which is here. Sorry, I put it in the wrong spot. And then D is 1, 2, 3, 4, 5 blocks away, so 1, 2, 3, 4, 5 blocks away. And that would be the shape, but that's not what I had. I had this. So I must have, after I reflected it, I must have done a slide, a translation. How many units, if this is my shape, how many units did it slide in which direction? Clearly it went left. And how many units? Well, how many blocks is this every time? 2. So left 2. So can you write words for these? You reflected over the y-axis, and then you went left 2. Now we're going to write a rule. Perhaps you remember the rule for reflecting over the y-axis, the x's change sign. The y coordinates, it doesn't go up and down, only the x coordinate side to side change. So my rule for reflecting over the y-axis is negative x. How do you do a rule for translate left? Left is off of the x-axis. Left and right goes with the x-axis. Right is positive, left is negative. So left 2 is x minus 2. My y's do not change. D is the same height here and here and here. So notice that my y's do not change. Only the y-axis or the x numbers are changing on those points. So we've written each step as a words and as a rule for that step. And here's the rule for the second step in words and the rule. So let's look at what happened to the points. A is the point -5, 4. The original point is -5, 4. The original B is -3, 5. The original C is -4, 3. And the original D is -5, 2. So we're filling those in. Now, what are the new points? Not this one from the reflection, the A prime. What is that point? Right 3, up 4. And B is right 1, up 4. And C is right 2, up 3. And D is right 3, up 2. These are my pre-image and my image. Now, we want to write one rule which will do both. Did my y change here or here? 4 goes to 4. 5, 5 shouldn't go to, that shouldn't change. That should, I made a mistake here. You have to fix my mistake. That should be 1, 5. 1, 5. It's 5. Make sure you fix that. It's 1, 5. The y's do not change. Y, 4, 5, 3, 2, 4, 5, 3, 2. So the y stays the same. Sorry about that. The x's are the ones that changed. How did the x numbers change? If you look at this, they flipped and they slid. C flipped and slid. B flipped and then slide 2 left. So it flipped over the y-axis, that's my rule -x, and then it went 2 left, that's my rule x minus 2. So we're going to combine those into one rule, -x minus 2. -x from here, minus 2 for the left. And that would be one rule to write for this instead of saying you need 2 steps. Okay, I know that's a little confusing, but if you think about it, I think you'll figure out we're just combining these rules to here. The next one at the bottom. How would you get from this shape to this shape? Is it a slide? Well, this C is 1 away, and this C prime is 1 away. So it's not just a slide because it has to flip over for the C to stay on the same side here. So it is a reflect over this line. Flip it over the y-axis. But if you flipped this over the y-axis, it would be here. And if you flipped this, it would be here. If you flip this, it would be here. So what's happening now to the whole thing? It's going up. How many does it go up? It has to translate up. D went up 2. A goes up 2. B goes up 2. So it goes up 2. So now we're going to write a rule. We reflect it, and then we slide it up. So the rule for reflect over the x-axis is x goes to negative x. X goes to negative x is the rule for reflect over the y-axis. The rule for translate up to is y plus 2. Up and down is y-axis, positive is up. So y plus 2. So that's one rule. Will you have to combine two things into one and write a rule? No. But if I give you this, should you be able to tell me where a point goes? Like if I say, where would the point 5, 6 go to? It would become negative 5, right? 5 becomes negative 5. And then y plus 2, 6 plus 2 is 8. That is something you would need to do. Vocabulary, these are called glide reflections. If you do a reflection and then a slide, they call it a glide reflection. I would think they would say slide reflection, but they don't. Okay. One more page. Reflections can be over any line. The equation of this line, the y-intercept is 0. The slope is up 1 over 1, up 1 over 1, up 1 over 1. So that is the line y equals 1x plus 0, mx plus b. We would just write it as y equals x, but 1x plus 0 is the same as y equals x. So we're going to reflect this triangle over this line. So visualize. This triangle flips this way and comes down here. So maybe it would help you if I drew it and then flip it. It's going to be down here. Okay? So what happens to those points? It's going to be somewhere down here. What happens to the points? Well, negative 8, 8. This point, where was that? If I trace it, A prime will come down here, right? Flip over the line and come down here. B prime will come down here, and C prime will come down here. So A prime, instead of being negative 8, 8, it's down here as the point over 8, down 8. So this is 8, negative 8. I moved my paper. So this reflects to here. Right there, that's lined up. 8, negative 8. B prime flips here. B prime is the point 10, negative 4. So here, I'll draw it on here. B prime is 10, negative 4. A prime is 8, negative 8. C prime would be here, touching the axis, so it's going to touch this axis. It flips over. So this is C prime, and that is 2, 0. So if I connect these, I get the exact same triangle flipped down. So what happened to the numbers? Can you write a rule? What happened to the numbers? From here to there, from here to here, from here to here. Didn't they just switch places? So XY goes to YX. Sometimes that confuses people. It's just numbers. Like this is going to be the number 2, 3. It would go to 3, 2. Just This is a rule for just saying flip the numbers. You know, math people, we like to try to make things a little more complicated than they need to be sometimes. Flip the numbers. What if you're going over the line y equals negative x? Y equals negative x, thinking of mx plus b, 0, and you're going to go, the slope is -1, so you go down 1 over 1, down 1 over 1. So this is my line, y equals negative x. And I'm going to reflect this polygon over this line. So I'm going to figure out the points. 1, -2. This is my point. 1, -2. It's got to come over here. On the other side of this line, it's got to come on the other side of this line. So here's the way I do it. And this is a little confusing maybe, but if I go up to get to the line, then I'm going to go out to get to A. So there's my A prime, and A prime is the point 2, -1. The whole shape flips. So I know A, if it starts on this side of the line, has to be on the other side of the line, the same distance away. B prime, B is the point -3, -3. So to get to the line, it's got to be over here on the other side of the line. So how do I get from B to the line? I go 1, 2, 3, 4, 5, 6 moves to get to the line, 6 blocks. So I have to go 6 blocks up. It's not this way over here off my paper because it needs to be up here. So 1, 2, 3, 4, 5, 6. C is, so what's that point? Let me fill that in. That's the point 3, 3. For C, C is the point -5, -1. I need C to end up on the other side of the line over here. So I have to go 1, 2, 3, 4, 5, 6 moves. So I'm going to go up 1, 2, 3, 4, 5, 6 moves. C prime is the point 1, 5. And then D. D was already on this side. So D has to go down here to the other side. D is the point 4, 1. So I go 1, 2, 3, 4, 5 to get to the line. So now I need to go down 1, 2, 3, 4, 5. And there's my D prime. I'll scooch the paper up so you can see it. So D prime is the point -1, -4. What happened to those numbers? Think about that. What happened to those numbers? I'm going to draw this shape. I'm going to connect A, B, C, and D. I think when I do that, you'll see it's the same shape as this trapezoid. That's what that's called, trapezoid. It's flipped over the line. If you fold on this line, they match up perfectly. C and B goes with C and B. D would match with D. A would match with A. So look at the points. What happens to the points? X, Y, the 1 goes there and the 2 goes there. These both became positive. That was negative, became positive. That was positive, became negative. They flip and change signs. You flip the numbers, reverse the numbers, and change all the signs to reflect over y equals -x. Now, On a test or a quiz, will you have to flip over crazy slanted lines? No, you're going to go over horizontal and vertical lines on a quiz or a test. But I wanted you to see how it works for slanted lines and how the slope relationships work. So there you go.